Greetings for the day, viewers. Let's start today's topic, data communication and network. Let's see the topic we will be covering under this section, routing algorithm and congestion control algorithm. Starting with routing. When a device has multiple paths to reach a destination, it always selects one path by preferring it others. The selection of process is termed as routing. Routing is done by special network devices called routers, or it can be done by means of software processes. The software-based routers has limited functionality and limited scope. Now, routing algorithm. Routing algorithm are as follows. Flooding. Flooding is the simplest method of packet forwarding. When a packet is received, the router sends it to all the interfaces except the one on which it was received. This created too much burden on the network and loads of duplicate packets wander in the network. Time to life (TTL) can be used to avoid infinite looping of packets. There exists another approach for flooding, which is called selective flooding, to reduce the overhead on the network. In this method, the router does not flood out on all interfaces but the selective ones. Shortest path. Routing decisions in networks are mostly taken on the basis of cost between source and destination. Hop counts plays a major role here. Shortest path is a technique which uses various algorithms to decide a path with minimum number of hops. Common shortest path algorithms are Dijkstra algorithm, Bellman-Ford algorithm, Floyd-Warshall algorithm. Congestion control algorithm. Congestion control refers to the mechanisms and techniques used to control congestion and keep the traffic below the capacity of the network. The congestion control techniques can be broadly classified into two broad categories. One is the open loop. Open loop protocols is to prevent or avoid congestion, ensuring that the system or the network under consideration never enters a congested state. Closed loop protocols that allow the system to enter a congested state, detects it and removes it. The first category of solution or protocols attempt to solve the problem by a good design at first to make sure that it doesn't occur at all. Once the system is up and running, mid-course corrections are not made. These solutions are somewhat static in nature, as the policies to control congestion don't change much according to the current state of the system. Such protocols are also known as open loop solutions. Main point here is that they make decisions without taking the consideration of the current state of the network. The open loop algorithms are further divided on the basis of whether these acts on source versus act upon destination. The second category is based on the concept of feedback. During operation, some system parameters are measured and fed back to portions of the subnet that can take actions to reduce the congestion. This approach can be divided into three steps. Monitor the system to detect whether the network is congested or not and what's the actual location of devices involved. Second, to pass the information to the places where actions can be taken. Third point, adjust the system operation to correct problem. The solutions are known as closed loop solutions. Various metrics can be used to monitor the network of congestion. Some of them are the average queue length, number of packets that are timed out, average packet delay, number of packets discarded due to lack of buffer space, etc.